Hello and welcome to your first video lesson. So we start with Chapter 1, Lesson 1, Expressions and Formulas. So today we're going to hit up order of operations. If you remember, that used to be in junior high, what you were calling PEMDAS. And then your freshman year, for those of you who had me, we started talking about GEMS. And so I'm going to review what that is and then and talk again about why I like that. So the G stands for groupings. And so a grouping is going to be anything like parentheses, maybe some brackets, absolute value bars, anything like that. E stands for exponents. Okay, so like x squared. By the way, did you know that a radical sign also is included in that? That's kind of getting into, I think that's Chapter 7 when we get to talk about that, but those square roots are going to fall into that as well. M stands for multiply or divide. Okay, multiply, divide. S stands for subtraction and addition. And of course, the reason I like this better than PEMDAS is this makes it a little easier for me to understand that multiplying and dividing are the same level of importance, just like subtraction and addition are the same level of importance. And so maybe I should make that note here to the side. When you're working with those multiplication, division, subtraction, addition, those you are going to work from the left to the right. Okay. Draw a couple arrows there. So let's do an example. We're going to be given an expression. Remember that an expression is kind of like an equation, but there will not be an equal sign. So it's going to be some numbers and variables there. So here it tells me m equals 12. I'm going to plug that in for m. It tells me q equals -1. Plug that in for q. So 12 plus parentheses 3 minus -1 squared. And of course I recognize I have a double negative, so I'll just go ahead and write that in real quick. And then I like to start with G, grouping. Do I see any groupings? Any parentheses, brackets, absolute value bars? Yes, I see 3 plus 1, which is just 3 plus 1, which is 4. Any more groupings or anything else I can do with those parentheses? Then go on to the next one, exponents. Are there any exponents? Yes, 4 squared is 16. Okay, now what? Multiplication, division. Do I have any multiplication, division? No. Move on. Subtraction, addition? Yes, I have a plus sign. The answer is 28. Okay, that's all we're doing for that first part. I think I want to try this next one just because it does do some interesting things. Oh, no, actually, let's skip down here and let's try number 4. That looks like a pretty complicated one. So I have j squared. So that's going to be -1. Tells me j is -1. Minus 3h. Oh, hang on, I know what h is. What is h? 4 squared, and k is 0.5. All over j, which is -1, cubed plus 2. Great. Let's simplify this. -1 squared. That is -1 times -1, and a negative times a negative is a positive, so that would be 1. Minus, I guess I should have paused for a moment. As far as the groupings go, when you have a fraction like this, you're going to imagine the entire top is a fraction, or is in parentheses, and the entire bottom is parentheses. Simplify those all the way down first before you try to do any division or anything, okay? All right. And so then after that, yeah, I see parentheses, but there's nothing to do inside the parentheses as far as adding or subtracting or anything like that. So I went straight to the exponents. How about 4 squared? Again, that is going to be 16, 0.5, all over -1 cubed is just -1, and then add 2. And so next I'm going to do multiplication. I'm going to take 3 times 16 times the 0.5, and I'm probably just going to plug all that into my calculator at the same time, or do it in my head, whichever way here. It's going to be negative 24. Looks like we're getting closer to an answer here. Now I can do addition, subtraction. 1 minus 24 is negative 23. And negative 1 plus 2 is going to be a positive 1. Now at this time, I have the entire top simplified, the entire bottom simplified. Now do that division. So negative 23 divided by 1 is just a nice, happy negative 23. All right, ignore that for your homework. That's not what your homework's going to be. We are going to quick do 1, 2 properties of real numbers because both these sections are pretty short. So we're just going to talk about these real quick. We're talking about irrational numbers. Irrational numbers are anything that can't be represented with a fraction or a nice happy decimal or whole number. So probably the most famous number that you know that would be a irrational number is actually pi. 3.14, and it keeps repeating forever. It never, or not repeating, it keeps going forever. It never repeats. I can't use any kind of fraction to represent that. That would be an irrational number. As with the square root of 3, if you've ever plugged that into your calculator, it's a pretty gnarly decimal as well. Next, we get to do rational numbers, and we use a Q for that. So a rational number is anything that's not an irrational number, basically, and not imaginary yet. We'll talk about imaginary numbers later. So like 0.125. That's a decimal that ends. It's nice and happy. I can put it as a fraction. What about 0.33 repeating? I can represent that as 1/3, so it's good to go. 2 would be a rational number. Okay, anything that's nice and happy like that. Next is going to be integers, and we use a Z for that. So an integer has no decimals, but it can be positive, negative, and it can also be 0 if you want it to be. Okay, and so on and so on. Next is going to be whole numbers. We're going to use a double for whole numbers. That's going to start at 0, and then it's all positive whole numbers, okay? And last but not least is going to be natural numbers. And natural numbers is going to start at 1, and then it's just going to count. You'll sometimes hear the natural numbers also called counting numbers because it's what you would count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay? So one of the things we're going to do today is kind of define what these are. A number can be more than 1. So for example, negative 185, that's an integer. And it's also a rational number. If I wanted to, I could just say Q and Z. By the way, all of these are going to be real numbers today, so you're also going to go ahead and drop a little R there. They're real numbers. They exist. I can have 3.14159 pieces of apple slices or whatever. It's really hard to get that exact, but it can be done. So like negative square root of 49. Square root of 49 is actually just 7. And there's negative on the outside, so it's negative 7. So it's a real number. All the numbers today are real. It's also going to be a rational number. And it's also an integer, so I can put a Z down as well. Square root of 95. When I plug that into my calculator, I got 9.746 and a whole bunch of more ugly decimals. It does not look like it repeats, so this one is irrational. It's still a real number, but it's irrational. Negative 7/8, that one's a real number. And it's a rational number, but that's it. All right, have that chart handy because it's makes life easy when you're doing that stuff. Okay, the book gives you super fancy, here's all the rules that we know that we can use. It doesn't matter what order we multiply or add in. That's what that says. I can add or multiply in any order, or the numbers can be in any order. If I add 0, the number stays the same. If I multiply by 1, the number stays the same. Here's inverses that make things cancel. Distributive property. There you go. These are all fancy things. You already know them all, even if you didn't necessarily know the name. And, you know, so like here, they're actually going to have us define what properties here. Looks like they just multiplied that too. So this is going to be the distributive property. Okay. Not going to worry about that today. Basically, we're going to be using those properties to simplify expressions. So they're still going to be variables when we're done. And again, ignore that. That's not what we're doing for homework. So I'm going to start by using the distributive property. 3 times 4x is 12x. And 3 times negative 2y is negative 6y. Distribute. Don't forget the negative sign. Negative 2 times 3x is negative 6x. And negative 2 times y is a negative 2y. And now you can combine like terms. So some like terms here that I see are the 12x and the negative 6x. So that's going to be 6x because 12 minus 6 is 6. And negative 6y minus 2y, negative 6 minus 2 is 8y. And that would be our answer. All right, that's it for today. I'll see you in our next class period where you get to work on your homework.